Identify the thermodynamic criteria for chemical favorability. A reaction is thermodynamically favored, spontaneous, when its standard Gibbs free energy change is negative, delta G degrees, less than 0. The relationship between Gibbs free energy, enthalpy, and entropy is defined by the fundamental equation. Delta G degrees equals delta H degrees, T delta S degrees, where T represents the absolute temperature in Kelvin, which is always a positive value. Determine the sign of the enthalpy change. Delta H degrees. The problem states that the dimerization of number 2 is an exothermic process. Therefore, heat is released, and the standard enthalpy change is negative. Delta H degrees less than 0 quad, negative. Determine the sign of the entropy change. Delta G degrees equals negative. T, negative. Delta G degrees equals delta H degrees plus T delta S degrees. The enthalpy term, delta H degrees, is thermodynamically favorable and drives delta G degrees to be negative. The entropy term, plus T delta S degrees, is thermodynamically unfavorable and drives delta G degrees to be positive. Determine the temperature dependence of favorability. At low temperatures, the magnitude of T is small, making the unfavorable term, plus T delta S degrees, very small. Under these conditions, the favorable negative enthalpy term dominates, resulting in a negative free energy change, delta G degrees, less than 0. At high temperatures, the magnitude of T is large, meaning the unfavorable term, plus T delta S degrees, increases and overcomes the enthalpy term, resulting in a positive free energy change, delta G degrees greater than 0. Therefore, the forward reaction is thermodynamically favored at low temperatures only, option B. The correct answer is option B, low temperatures only.